In today's video, we'll be looking at how to solve problems involving factorization. Now, all the questions that we'll be looking at today were all retrieved from the most recent Csec past papers, so you want to stick around for that. If you're new to this channel, please hit that subscribe button and the notification bell to be notified whenever we post new videos. If you also want to see more Csec videos, please check out that description section below titled More Csec Videos. Alright guys, so these are the questions that we'll be looking at today, and as always we'll be starting off with the January 2017 paper. So we're starting from old to new. Alright, so as usual you can pause the video, you can always attempt these questions and then resume the video, alright, and watch and see the correct solution for each problem. Alright, so let's get right into it. Alright, so here we have the January 2017 paper, and this asks us to factorize completely x squared minus 36. Alright, and you would have observed based on the question that were displayed that there's two parts to this question. Alright, but we'll first look at the first part of the question, which is x squared minus 36. Alright, and this actually meets the criteria of difference of two squares. Alright, so we're going to use the difference of two squares method to treat with this. Alright, so x raised to the power of 2, we can rewrite that as x in bracket all squared. That's the same thing. And 36 is the same thing as 6 squared. Alright, so here we have the difference of 2 squared. Alright, so that's where it got its name from. And we can, based on how we treat with difference of 2 squared, so here we have x squared and we have 6 squared. So what we can do now, we can put the x, keep the sign right here, which is minus, and the 6 right here in one bracket. Then we'll write back the same two terms. All right, the only thing that we're going to change is this sign from negative to positive over here. So instead of writing x minus 6, we'll write x plus 6. All right, you might be wondering if it's that easy. Yes, it's that easy. All right, so there's nothing to it. So this is pretty much how we treat with something like this. All right, so basically what you did was to square root the x squared. That would give you the x. You keep the minus sign, you square root 36, that's 6, and you just rewrite this thing. All right, x, you just change the sign from minus to an addition sign, and then you write the 6 right there. All right, and that's pretty much how you treat with part 1 of the question. Alright, now part 2 wants us to factorize completely 2x squared plus 5x minus 12. Alright, and we can always use the AC method to treat with this part of it. Alright, so first thing first, we want to find AC, and again our A would have been the coefficient for the x squared term, so that would have been 2, so our A is equal to 2. Our B would actually be the coefficient of the x term, so our B would be equal to 5, and our C is the constant out here, which is negative 12. All right, so how do we find our AC? We find our AC by simply multiplying what? The value of A times the value of C. So that would be 2 times negative 12, and that gives us negative 24. Now what we want to know now is which two numbers we can multiply to get negative 24, that when we add or subtract those numbers, we'll obtain our B value here, which is 5. Alright, so the positive number must be greater than the negative number, alright, in order for us to obtain a positive 5. So let's see, if we have positive 24 times negative 1, that can give us negative 24. Let's look at some other ones. Alright, positive 12 times negative 2, that can also give us the negative 24. We can also have what? 8 times negative 3, that can also give us the negative 24. And 6 times negative 4. That will also give us the negative 24. All right. So which of these groups, when we look at them, if we should add or subtract any of these two numbers, we can obtain 5 right here. All right. Obviously, it would actually be this one right here. All right. So if we should have negative 3 plus 8, that will actually give us the 5. All right. So this is the one that we'll be using. So instead of to write back 5x, we're going to expand the 5x by writing it as negative 3x plus 8x. All right. So this will actually give us back the 5x. So we're pretty much expanding this 5x here. So we're rewriting it. And this is the method that we use to do so. All right. So here I have 2x squared plus 5x minus 12. And again, here I have the 2x squared. Now I'm going to replace the 5x with negative 3x plus 8x. So here I'll have what? Negative 3x plus 8x minus 12. All right. And notice if we should simplify this thing, we're going to end up back with the 5x. All right. Because negative 3x plus 8x is the same thing as 5x. All right. What we can do now is to group these things. All right. So we can group the first two terms. So we can group 2x squared and minus 3x. Have the plus sign there. We can group 8x and the minus 12. All right. Now, what else can we do now? We can factor out what's common. So in this, we know that we can get an x out of this. We can factor out x. If we factor out x, what would we be left with inside the bracket? We're left with 2x minus 3. All right. Right, back the plus sign there. What can we factor out of this? Now we can factor out 4 out of this. If we factor out 4, we'll be left with 2x minus 3. Alright, so we factored out the highest common factor for both numbers, which would have been 4. Then you simply just divide each term by what you would have factored out. So 8x divided by 4, you will get 2x. Negative 12 divided by 4, you get negative 3. Alright, and the key thing to notice is that we got the same thing in both brackets. Alright, so if you're not getting the same thing in both brackets, then you know that something is wrong. Alright, so this should always happen. Now what we're going to do is to write down the common bracket, which is 2x minus 3, and we're also going to put the outside terms in one bracket. So we are going to have the x plus 4 in one bracket. Alright, and that's pretty much how you factorize 2x squared plus 5x minus 12. Alright, so that's how you factorize that right here. So 2x squared plus 5x minus 12 is the same thing as 2x minus 3 in bracket and x plus 4 in bracket. Alright, so that is pretty much how we treat with part 2 of the January 2017 paper. Alright, let's look at the January 2017 paper. Alright, so this asks us to factorize the following expressions completely. Alright, and there is actually 3 parts to this question, but let's first look at part 1. So here we have 6y squared minus 18xy. Alright, so what we want to do now is to factorize this thing. And how can we do that? We can look at what we can get out of both these terms. What is common in both these terms? So we want to factor out the highest common factor out of both these terms. Alright, so let's first look at the numbers. Alright, and if you want to learn more about factorizing algebraic expression, I'll have a video of that in the description section below that you can check out. So if you want to learn that from scratch, you can check out that video titled Easiest Way to Factorize Algebraic Expressions in the description section below. Alright, so let's get right back at this thing. So what we can do is to first look at the numbers. Alright, so what is the highest common factor for 6 and 18? Of course, that's 6 from both these terms. Alright, then we'll put our bracket there, and now want to divide each term by the 6y. So 6y squared divided by 6y, I'll be left with y. Put back my minus sign there. 18xy divided by 6y, I'll be left with 3x. Alright? So that's pretty much how you treat with this part of the question. Alright? So it's quite easy. And you can always check your answer if it is correct. So this is actually the solution for the problem. Alright? Quite easy. Now what you can do to check if your answer is correct, you can always expand out this thing. Alright? So 6y times y, that will give you 6y squared, minus 6y times 3x, that will give you 18xy. Alright, so that proves that our solution was actually correct. Alright, and that is how we treat with the first part of the question. Alright, so let's look at the second part of the question. Alright, so here we have 4m squared minus 1. Alright, so how do we treat with something like this? Again, this meets the criteria of difference of 2 squared. So we can first find the square root of 4m squared. What's the square root of 4? Square root of 4 is 2. What's the square root of m squared? That would be m. We have our minus sign. What's the square root of 1? That's 1. And all we need to do is to write back the same 2 term, but change the sign that to addition. Alright, so this is 2m plus 1. Alright, so that's pretty much how you treat with this, because if you look at this, 4 is the same thing as 2 squared, and m squared is the same thing as m squared. So we can have 2m in bracket all squared. If we square 2m, we'll obtain 4m squared, minus 1 is the same thing as 1 squared. Alright, so this meets the criteria of a difference of 2 squared. Alright, and that is how we treat with this particular question, as demonstrated in the January 2017 paper. Alright, so that's pretty much it for part 2. Alright, so let's look at part 3 of the question. So here we have 2t squared minus 3t minus 2. Alright, so again, we want to factorize this question, and it's quite easy. So we can use the same AC method to do this. So again, our a would be the coefficient of the squared term. Our b would be the coefficient of the t term, and our c would actually be the constant out here, so which is negative 2. So our a is equal to 2, our b is equal to negative 3, and our c value would be negative 2. Alright, again, we can always obtain our AC by simply multiplying the value of a times the value of c. Alright, so that's 2 times negative 2. That will give me a negative 4 right here. Now what we want to know is what we can multiply to get negative 4 when we add or subtract those things. It can give us our b value, which is negative 3. Alright, so how do we go about doing this? So again, how can we obtain negative 4? And notice that our b value is negative 3. So that means that the larger number must be a negative number. Alright, so we can get negative 4 by simply multiplying negative 4 times 1. We can also get negative 4 by multiplying negative 2 times 2. Alright, and of course, if we add a negative 4 and 1, we can obtain negative 3. Alright, so we can expand this negative 3t by simply rewriting it as negative 4t plus 1t. Alright, which is the same thing as saying negative 4t plus t. Alright, so I'm going to expand this thing now. So here I have 2t squared minus 3t minus 2. Again, we write back the 2t squared, and I'm going to replace the negative 3t with minus 4t plus t, alright, which is the same thing as negative 3t minus 2. Now what we can do now is to group the first 2 terms and the last 2 terms. So we have 2t squared in one bracket minus 4t. Put back our positive sign, and we have t minus 2 out here. Alright, now what can we do now? We can factor out the highest common factor out of these 2 terms. Alright, and that would be 2t. So if we look at the numbers first, what's the highest common factor for both numbers? Of course, that's 2. And we can get a t out of t squared and t, alright? So we factored out 2t, alright? So what will we be left with in bracket? We'll be left with, if we divide 2t squared by 2t, we'll be left with t minus, if we divide 4t by 2t, that will leave us with 2, alright? Plus, we can factor out a 1 out of this, alright? And we'll still have the t minus 2 inside the bracket, alright? Notice when we factored out the 1 out of this, if we should multiply the bracket by 1, doesn't change the value of the thing, alright? Now what we're going to do now, again, just like the previous example, we're going to put the common brackets, and again, this is always important. We have to get the common brackets, alright? So if we're not getting this, then something is wrong, alright? So we're going to put the common bracket in one bracket down here, and we're going to put the outside terms in the other bracket. So 2t plus 1 in the other bracket, alright? So this is pretty much our solution, alright? So that's pretty much it for this question. So 2t squared minus 3t minus 2 is equal to t minus 2 in one bracket and 2t plus 1 in the other bracket. Alright, so that's pretty much a solution for part 3, and that's the end of the June 2017 paper. Now let's look at the question that was given on the June 2018 paper, alright? So this asks us to factorize completely each of the following expressions, alright? And again, this question has 3 parts to it, alright? And as always, we'll look at part 1 first, and then we'll treat with the others as they come, alright? So here we have 1 minus 4h squared, and again, this is a difference of 2 squared problem, alright? So 1 is the same thing as 1 in bracket squared minus, if I find the square root of 4, that's 2. The square root of h squared is h. If I put those two things in bracket and square, then it's the same thing as 4h squared, alright? Now what we're going to do now is to write the 1 in there. So we have the 1, put back the sign, which is minus, then a 2h, close bracket, and in the other bracket, we'll rewrite these two terms, but change this negative sign to a positive or addition sign, alright? So 1 plus 2h, alright? So the same two terms, just change the sign to positive sign over here, alright? And as always, you could also look at the question as you just square root 1. The square root of 1 is 1. Put back the minus sign. The square root of 4h squared is 2h. And you put that in bracket, and you write back the same two terms in the other bracket, and just change the sign from negative to positive over here, alright? And that is pretty much how you treat with the first part of this question. Alright, so let's look at part 2 of the question. So here we have pq minus q squared minus 3p plus 3q. And again, they want us to factorize completely this thing, alright? This expression. Now we can do so, being that we have 4 terms, we can do that by using the method of factorization by grouping, alright? Or factorizing by grouping. So what we can do, we can group the first 2 terms. So we have pq in one bracket minus q squared, and put back our minus sign. Now the key thing about this, if we add a minus sign out here, that will affect what will go inside of the bracket. So we'll have 3p minus 3q, alright? And you might be wondering, how comes he changed a positive sign to a negative sign here? Alright, if you look at this thing, if I should multiply this entire bracket by the negative sign out here, I should actually obtain the same thing that I had here. So negative times 3p would give me the negative 3p. Negative times negative 3q would give me a positive 3q, alright? So that's why I did that. Now what we can do now is to factor what's common in both terms in both brackets, alright? So here we know that we have a pq minus q squared. We can get a q out of this. So we'll factor out q, we are left with p minus if we divide q squared by q, we'll be left with q. All right, have our minus sign out here, and we can factor out 3 from both these terms. All right, so we have 3 is common here, so factor out 3, and we're left with p. If we divide 3p by 3, we'll be left with p. If we divide 3q, put back the minus sign here, if we divide 3q by 3, we'll be left with q. And again, as always, it's very important to obtain the same thing in both brackets. All right, that tells us that we are on the right path. All right, now what we're going to do is to put the common bracket over here. So we are going to record one of the common brackets, and in the other bracket we'll record the outside term. So we'll have q and the minus 3 in the other bracket. All right, and that's pretty much how we treat with this question. All right, so this is a solution for the question. So pq minus q squared minus 3p plus 3q is equal to p minus q in one bracket and q minus 3 in the other bracket. All right, and that's pretty much how we deal with part 2 of the question. Now let's look at part 3. All right, now let's look at part 3 of the question. All right, so here we have 2x squared plus 5x minus 3 is equal to 0. So this is an equation and not an expression, so we can obtain some results for this. All right, and being that this is a quadratic equation, we will obtain 2 results. All right, now what we can do, we can use 2 methods to solve this, and I'll demonstrate the 2 ways how we can solve this thing. All right, so we can use the AC method, and we can also use the quadratic formula. So first up, I'll use the quadratic formula. So x is equal to, so recall the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, now what will this give us? So again, we can always identify our a, b, and c respectively. Our a is the coefficient of the x squared term, which is 2. Our b would be the coefficient of the x term, which is 5. And our c would be the constant out here, which is negative 3. All right, now what we want to do now is to plug in those values in our formula, and we'll be on our way. All right, so we'll replace the b with 5 because b is the same thing as 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 2, times c, which is negative 3. And I have to extend this square root sign some more, over 2 times a, and my a value is 2. All right, coming down, here we have negative 5 plus or minus the square root of, let me see, what's 5 squared? 5 squared is the same thing as 5 times 5, which is 25, minus 4 times 2, that's what, 8. 8 times negative 3, that's negative 24. All right, all over 2 times 2, which is 4. So 2 with 2 in the bracket is the same thing as 2 times 2. All right, same thing apply for these right here. So here we have negative 5 plus or minus the square root of 25. And whenever we have 2 negative signs like this, and if you're not good with integers, you want to check out that video that I have in the description section below, titled Easiest Way to Learn Integers. All right, so whenever we have 2 negative signs like this, those are equivalent to a positive sign. So this is the same thing as saying 25 plus 24, all right, over 4. This will give me negative 5 plus or minus the square root of 49 over 4. All right, So 25 plus 24, that's 49. All right, what do we have now? So we have negative 5 plus or minus the square root of 49, that's 7 over 4. All right, and we're traveling well. So what we can do now is to split this thing, being that we have a plus or minus sign here. So we know that we'll have x being equal to negative 5, and I'll just take the positive sign for now, plus 7 over 4. All right, and we'll also have a x value being equal to, again, negative 5. This time I'll take the minus sign, minus 7 over 4. All right, so what does this thing gives us? We'll end up with x being equal to, what's negative 5 plus 7? That's a positive 2 over 4. All right, which is the same thing as x is equal to, if we reduce this thing, 2 into itself goes 1, 2 into 4 goes 2. So x is equal to a half. Now what we can do is to actually go about finding the other x value. All right, so being that x is equal to negative 5 minus 7 over 4, we can say that x is equal to negative 5 minus 7. That's the same thing as negative 12 over 4. All right, and negative 12 divided by 4 will give us a negative 3 right here. All right, and that's pretty much how we treat with this particular question. So our result will give us x to be equal to a half and x to be equal to negative 3. All right, so as I outlined previously, being that this is a quadratic equation, we'll obtain two values for x. All right. All right, now let's look at the alternative method. As I mentioned before, we could have also used the AC method to solve this thing. All right, and again, our A would have been what? The coefficient for the x squared term, which is 2, and the coefficient for the x term, which is 5, and the constant, which is negative 3. All right, so that's pretty much our A, B, and C respectively. All right, so if we want to use the AC method, again, we need to find our AC, and we can obtain that by simply multiplying our A value and our C value. All right, so 2 times negative 3, that's negative 6. All right, now we want to find the factors of negative 6. All right, I want to know two factors that when we add or subtract them, we can obtain our B value right here. So right away, we know that our B value is a positive value, so bigger number must be positive. All right, so 6 times negative 1 will give us 6, and we also know that what 3 times negative 2 will also give us negative 6. All right, so which of these can we add or subtract to give us our positive 5? Of course, it would be this right here. All right, because look at this, if we should have negative 1 plus 6, that gives us positive 5. All right, so we are going to rewrite 5x as negative x, which is the same thing as negative 1x plus 6x. All right, same thing as 5x. Now we have 2x squared plus 5x minus 3. So I just wrote back the equation. And again, as I mentioned before, we are going to replace this 5x with negative x plus 6x minus 3 is equal to 0. All right. Now, what can we do now? We can group the first two terms and the last two terms. All right. So we can have 2x squared in one bracket minus x, and we can have 6x minus 3 in the other bracket. Now we are going to factor out what's common in both brackets. All right, so we can get an x out of this, and if we do that, we'll be left with 2x minus 1. So we simply factored out what was common and then divide each term by what we factored out. So 2x squared divided by x, that will give you 2x. X divided by x is 1. Right? So if you divide anything by itself, of course, that's 1. And here we notice that what's the highest common factor for 6 and 3? Of course, that's 3. So we can factor out 3 out of this thing. Now 6x divided by 3, that's 2x minus 3 into 3 goes one time, and all of that is equal to 0. Now, again, as always important, we obtain two brackets with the same thing, alright? So that let us know we're on the right track. So we can have the common brackets. We are going to bring down one of the common brackets, and in the other bracket, we are going to have the outside term, so x plus 3, alright, is equal to 0. We can now equate each bracket to the 0, so we can have 2x minus 1 being equal to 0, and x plus 3 being equal to 0. Alright, so again, we'll get the same values for x, so we'll have two values for x. Alright, so let's transpose this part of it first. So if we want to get rid of the negative 1, so again, when we're transposing, we do the opposite of the operation that is taking place to remove something. So if we want to get rid of this negative 1, we have to do the opposite, which is to add 1. And if we add 1 on that side, we're required to add 1 on the other side as well, alright? So negative 1 will cancel positive 1, so we're left with 2x is equal to 1. And now, if we want to get rid of the 2, 2x is the same thing as 2 times x. So to get rid of the 2, we have to do the opposite, which is division. And if we divide one side by 2, we are required to divide the next side by 2 also. So 2 cancel 2. And x is equal to 1 over 2. Alright? And over here, if we want to get rid of this positive 3 from over here, we have to do the opposite, which is to minus 3. And if we minus 3 on this side, we're required to minus 3 on the other side as well. So 3 minus 3 cancels, and x is equal to negative 3. Alright, so therefore, again, our values would be the same. So x is equal to a half, and x is equal to negative 3. Alright, so you choose which method you want to use. You could use the quadratic formula as I previously demonstrated, or you can use the AC method to solve this thing. Alright, so that's pretty much that for this question. Alright, now let's look at the question that was given on the June 2019 paper. So this asks us to simplify completely on part 1. And again, this question has two parts to it, but we'll look at part 1 first. So part 1 asks us to simplify completely 3p squared times 4p to the 5th power. And we can approach this question two ways, alright? Now let's look at the first way. So we can expand out these things first. So we can have 3 times p squared, same thing as p times p, alright, times 4, and p to the power of 5 simply means that we'll multiply p by itself 5 times, alright. So we can do that. Now 3 times 4, that's 12. And we'll now count the amount of p's that we have, which is 1, 2, 3, 4, 5, 6, 7. So we'll have p to the 7th power, alright? Because we're multiplying p 7 times. So 1, 2, 3, 4, 5, 6, 7. And this is actually our solution, alright? So this would be our answer. Now another way how we could look at it, so this is an alternative method now. Alright, so alternative method, alright, so here we have the same 3p squared times 4p to the 5th power, alright. So again, we can multiply the numbers, so 3 times 4, that's 12, and because we have p squared times p to the 5th power, being that both the bases are the same, so we have p here, and we are multiplying them, so we can have p according to the law of indices, alright? So this is our law of indices because the bases are the same. So if I have a to the n power times a to the m, then this is the same thing as saying a to the n plus m, alright? So this rule applies to this scenario as well. So p squared times p to the 5th power is the same thing as saying p to the 2 plus 5, alright? And so this is the same thing as 12p, 2 plus 5, that's 7, alright? So either way you want to do it, you'll get the same answer, alright? So this is some indices here for you. If you're not interested in this, then you can do it like this. All right, so the good thing about maths, there is more than one way to solve a problem. All right, now let's look at part 2 of the question. All right, so this is part 2, and now we're required to simplify completely 3x over 4y cubed divided by 21x squared over 20y squared. All right, so how do we go about this thing? All right, now here we have some fractions, and a key thing when dividing fractions, what do? We keep the first fraction, so we keep the 3x over 4y cubed, and we change the division sign to multiplication, and then we flip the second fraction. So 21x squared over 20y squared will become 20y squared over 21x squared. All right. Now what we can do now is to multiply numerator by numerator. All right. So 3x times 20y squared, we can look at the numbers first. So 3 times 20, that's 60 right there. X times y squared is xy squared over 4 times 21, that's 84, if I'm not mistaken. Y cubed times x squared is the same thing as x squared y cubed. All right. Now we can reduce this thing. All right, so how do we go about reducing this thing? We can expand the numerators if we want to. So we can say 60 times x times y squared is the same thing as y times y over, this is the same thing, the denominator now. So 84 times x squared is the same thing as x times x times y cubed is the same thing as y times y times y. All right, so what we can do now is to look at the numerator and denominator and see what we can cancel. All right, now we'll look at the 60 and the 84. What's the highest common factor for both these numbers? Of course, that's 12. All right, so 12 going to 60 5 times, and 12 goes into 84 7 times. All right, what else do we see going on here? We can use a x to cancel x here, can use a y to cancel y, another y to cancel another y, so we'll be left with 5 over 7. All right, so 12 going to 60 5 times, 12 going to 84 7 times. All right, so we'll be left with 7 times x times y, so that's 7xy. All right, so our answer is 5 over 7xy. All right, and if you're good with indices, you can play around with it. So this is pretty much the answer, right? So if you're not good with indices, you can stop here. If you are comfortable with indices, you can rewrite this thing as 5 times x to the power of -1 times y to the power of -1 over 7, all right, which is the same thing. All right, however, if you're not comfortable with indices, this is perfectly fine. All right, so that's pretty much how we treat with the second question that was given on the June 2019 paper as it relates to factorization, and that's pretty much how we treat with factorization as it relates to the June 2019 paper. Now let's look at the final paper, the January 2020 paper. All right, so now we're looking at the January 2020 paper, all right? And this asks us to factorize the following expressions completely. And there is 2 parts to this question. And as always, we're going to look at part 1 first, all right? So here we have 5h squared minus 12hg. Now what we want to do is to factor what's common. All right, what's common in both terms? So let's look at this thing. We can get an h out of h squared, and of course we can get h out of h, so we can factor with h out of this thing. If we do that, what we can do now is to divide each term by what we would have factored out, which is h. So 5h squared divided by h, we're left with 5h minus, so we'll bring back the minus sign, 12hg divided by h, that will leave us with 12g. All right, and that's pretty much how we treat with the first part of this question, all right? And if you want to check and see if your answer is correct, you can expand this thing out, all right? So h times 5h, that will give you the 5h squared minus h times 12g is 12hg, all right? So that let us know that we would have done the correct thing, all right? So that's how you pretty much treat with the first part of the January 2020 factorization question, all right? Now let's look at part 2 and the final question that we'll be looking at in this video. All right, so this is what we have in part 2. So we have 2x squared minus x minus 6, all right? Now, how do we treat with something like this? As we have done several times already in this video, we're going to use the AC method to solve this thing, all right? And again, our A would actually be the coefficient. Coefficient simply means the number that's in front of the x squared term. So the coefficient of the x squared term, and that's 2. B would be what? The coefficient of the x term. So that's the number that would be in front of the x. And you might be wondering, there's no number there. It's just a negative sign, all right? So negative x is the same thing as negative 1x, all right? So we can look at that as a negative 1. And now our C would be the constant, which is negative 6, all right? Now, what do we need to do? We need to find our AC, all right? How do we do that? Again, we find the product of our A and our C value. So 2 times negative 6, that will give us negative 12, all right? Now we want to find out what can we multiply, which two numbers can we multiply to get negative 12. When we add or subtract those numbers, we'll obtain negative 1, all right? And being that B is negative 1, that tells us that the larger number that we're looking for must be a negative number, all right? So we'll have negative 12 times 1, that gives us negative 12. We know that what? Negative 6 times 2, that also gives us negative 12. We also know that negative 4 times 3, that will also give us a negative 12, all right? So which of these groups, if we add or subtract, we can obtain the negative 1 right here? Of course, it would be this one right here, because negative 4 plus 3 will give us the negative 1, all right? Which means we can expand this negative x here. We can rewrite that as negative 4x plus 3x, all right? That's the same thing as negative x, all right? So I'm going to bring this thing down now. So I have 2x squared minus x minus 6, all right? So I have 2x squared. And again, I'm going to rewrite the negative x as negative 4x plus 3x, all right? So negative 4x plus 3x. And I still have the minus 6 here. Now I'm going to group the first two terms and the last two terms in one bracket. All right, so first two terms in one bracket, last two terms in another bracket. And again, what we're going to do is to factor what's common among the terms, all right, in the bracket. So what's common in 2x squared and negative 4x? So what we want to look at is the highest common factor. And what is that? If we look at this thing, look at the numbers first. The highest common factor for 2 and 4, of course, that's 2. We have x squared here and x over here, so we can factor out the x out of that. Now what we want to do now is to divide each term by what we would have factored out, which is 2x. So if we divide 2x squared by 2x, we'll be left with x minus 4x divided by 2x, that's 2, plus, what can we factor out of this thing now? What's the highest common factor for 3 and 6? Of course, that's 3. And if we divide 3x by 3, we'll get x minus 6 divided by 3, that's 2, all right? And what we are going to do now, again, before we even move on, this is always important to obtain the same thing in both these brackets, all right? That let us know that we are on the right track. Now what we want to do now is to bring down one of the common brackets, which is x minus 2. And in the other bracket, we'll have the outside terms. So 2x plus 3 over here. All right. And that's pretty much how we treat with the question. All right. So that's pretty much it. So we would have completed the question. So 2x squared minus x minus 6. So if we factor this thing, we'll obtain x minus 2 in one bracket and 2x plus 3 in the other bracket. All right. And this is where we'll end today's video. All right, guys. So don't forget to like this video. If you haven't yet done it, please hit that subscribe button and the notification bell to be notified whenever we post new videos. As always, thanks for watching.